Okay, so let's get started with our first running of OpenMP on some C code. So here is a very simple Hello World C program, including standard I/O and printing Hello World, and we should be able to compile this and run that as you'd expect with any sort of C program. And this is a sequential program. It's a single thread of execution. Hello world is printed, then return 0, successful exit code comes out. We start at the top and we go down to the bottom. So this is the sort of standard way we've been programming for years previous to this. So what we're going to do now is we're going to add threading to this. And in order to do that, we need to do a couple of things. First thing we need to do is we need to include the OpenMP headers that come as standard with GCC. And then we've included them, but we're not actually defining any sort of parallelism or parallel regions within the code. So the next thing we need to do is we need to use a pragma statement. You see VS Code is helpfully providing suggestions there, but we can use pragma OMP parallel. This defines what's called a parallel region. So we're saying, okay, execute everything after this as parallel. Now, without any braces, it would just do the next line as any sort of standard construct. We're just going to put the braces in. Let's indent that and come back. So we now have our code. We have our included OMP header library, and we've also put the compiler directive in pragma OMP parallel. So if we now compile this again and run it, we get exactly the same output we got last time. So why? Well, okay, we've put these includes in, we've put this region in, but what we haven't done is the step of linking to the OpenMP library at compile time. So we do that with this switch to the GCC compiler. We've now compiled with everything we need, and when we run Hello World, what we now get is we don't get one instance of Hello World, we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, we will come on later on to look at ways in which you can change this, but for now all we need to know is that this computer that I'm compiling and running on, a Mac M1 Pro, it has 10 cores in it. By default, OpenMP will create a thread team over the number of cores. We have 10 cores, it has created 10 threads, and each of these threads have then printed out Hello World. We can see the difference in terms of action if we go back in and we put another printf afterwards, nip back and compile this, and then run it. You can see that we go through our parallel region, we split into our thread team of 10 threads, each one executes the same code, Hello World, and then once they've finished, we get to Goodbye World, which is printed once, because at this point we've collapsed back, we've rejoined to a single thread of execution. So that's the basic operation of OpenMP. As I mentioned, just to show what we can do is we can get rid of the braces, at which point, as with any sort of C construct where we don't have the braces inside, there's no code block, the next code block is just a single line of execution. So in this case, it's not going to make any difference to us. But if we wanted to perhaps print hello and then print world, and we want both these to be executed in parallel, without the brace, you can see we get 10 hellos, but only one world and one goodbye world, because this is the parallel region, and then these are back into single threaded execution. If we put them in a block, we then get hello world, hello, hello, hello world, hello world. What we're starting to see here is issues with interleaving. And again, this is something we'll come back to look at in more detail. But what's happening is as the threads go through, a thread will print hello, another thread prints hello before the first thread has printed world. So we then get, perhaps this is the first thread, it gets all the way through okay, but this one prints hello, but before it can print world, another 2 threads have printed hello. And this is where we get into the more complicated structures and ways of working through. So that's the very most basic introduction. That's how we created parallel region using the Pragma OMP parallel. We include omp.h at the top, and we create our parallel region. This is executed in parallel. As I say, by default, just the number of threads will be the number of cores in our processor or available in our machine, and then we rejoin at the end. Let's just quickly re-put that in to avoid confusion. And let's add a second parallel region. So we now have a second parallel region. Just indent that for clarity. Single instruction, so we have one parallel region up here where we form a team of threads and we execute. We rejoin here. We form another parallel region here, and then we execute this in parallel. So have a think, what do we think the output's going to be? Do you think we're going to get hello world interleave with goodbye world, or we're going to get hello world and then goodbye world? Let's have a look. So yeah, hello world, goodbye world, in order. Why is that? Well, because these are 2 separate parallel regions, and because we finish a parallel region, the threads all come back together here. At this point, we're back to being a single thread of execution, and then we branch out again. So these 2 are run differently. If, however, we merged these into a single parallel region, you can see we're starting to get the interleaving. Usually, in most cases, it's hello goodbye, because that's one thread printing hello goodbye, hello goodbye, hello goodbye. But then this one's printed hello, the next thread prints hello, and then they're both printing goodbye at the end, which just hints at some of the complexity and some of the considerations that need to be taken into account later on. But as I say, that's the most basic introduction to starting parallel threading with OpenMP.